Now we move on to straight line. If a line makes an angle theta with positive x-axis in a positive way, then theta is the inclination of the line. If the inclination of theta is, if the line is theta, then slope is m equal to tan theta. For the horizontal line, theta equal to 0. So slope is 0. For vertical line, theta is 90. The slope is undefined. For the slope of the line connecting the points b of a and b equal to m equal to y2 minus y1 by x2 minus x1. The two we have two parallel lines, then their slopes are equal. If the lines perpendicular to each other, then the slopes m1 m2 equal to minus 1. Equation of horizontal line passing through the point x0 y0 equal to y0. Equation of vertical line passing through point x0 y0, then x equal to x0. Suppose general equation we take ax plus by plus c equal to 0, slope equal to minus a by b. Let us take two general equations, a1 x b1 y plus c1 equal to 0, a2 x plus b2 y plus c2 equal to 0. They are parallel lines. Parallel means a1 by a2 equal to b1 by a2. If they are coincide means a1 by a2 equal to b1 by b2 equal to c1 by c2. If they are perpendicular means a1 a2 plus b1 b2 equal to 0. Equation of a straight line. Let us take the intercept form x by a plus y by b equal to 1, where a equal to x intercept and b equal to y intercept. This type of area of triangle AOB here, half mod AB, mod AB. If line ax plus by plus c equal to 0, then its x-intercept and y-intercept will be minus c by a minus c by b, and the area made by the line and the axis are c square by 2 mod ab. Let us move on to 2-point form. We can simply simplify it by m is nothing but here y2 minus y1 by x2 minus x1 is nothing but slope. It is similar to the slope point form. Suppose the line is passing to x1 y1 and having the slope m, then y minus y1 equal to m into x minus x1. Now we move on to normal form. Equation of line p units away from the origin. Equation of line, okay, which is p units away from the origin, and normal makes an angle alpha with the origin, with the x-axis. Therefore the equation of line is x cos alpha plus y sin alpha equal to p. X cos alpha plus y sin alpha equal to p. Here the length of perpendicular from origin to the line x plus by plus c equal to 0. equal to the length p equal to mod c by root over a square plus b square. Suppose the length of perpendicular from any point x naught y naught to the line will be mod of a x naught plus b y naught plus c by root over a square plus b square. Now we move on to parametric form or symmetric form. Line passing through point x1 y1 and makes an angle theta with the x-axis would be x minus x1 by cos theta equal to y minus y1 by sin theta, which is a symmetric form. Let us move on to parametric form. In parametric form, the line passing through x1 y1 with inclination theta, then the coordinate x equal to x1 plus r cos theta, y equal to y1 plus r sin theta, where r is parameter. Suppose p is point on the line which is x units away from the point x1 y1, then the p can be determined by 2. We get 2 points which is away from the r units. First point coordinates would be x1 plus r cos theta, y1 plus r sin theta. Another point would be x1 minus r cos theta, y1 minus r sin theta, or sin theta. Now we discuss the general equation of the line ax plus by plus c equal to 0, which slope we already known, minus a by b, and x-intercept here minus c by a, y-intercept here minus c by b. Let us move on to the position of a point. It's related to the line ax plus by plus c equal to 0. Suppose the ratio in which this line divides the line segment AB, line segment joining the points AB, would be minus L11 by L22. This is the ratio in which the line divides the line segment AB. Here L11 equal to ax1 plus by1 plus c, L22 equal to ax2 plus by2 plus c. Suppose if L11 and L22 have opposite signs, then AB lies on the opposite side of the line L equal to 0. If L11 and L22 have same signs, then AB lines on the same side of the line L equal to 0. L equal to 0. Equation of the line which is parallel to ax plus by plus c equal to 0 is ax plus by plus k equal to 0. Suppose we have two parallel lines, then the distance between the parallel lines would be first line ax plus by plus c1 equal to 0, second line equal to ax plus by plus c2 equal to 0. Then the distance between them is mod c1 minus c2 by root over a square plus b square. Okay, equation of the line passing through x1 y1 and parallel to ax plus by plus c equal to 0 is a x minus x1 plus b y minus y1 equal to 0. Now we move on the perpendicular lines. Suppose ax plus by plus c equal to 0, then its perpendicular line formula, the perpendicular line equation could be bx minus ay plus k equal to 0 is suppose equation of line passing through x1 y1 and it is perpendicular to x plus by plus c equal to 0 is b into x minus x1 minus a into y minus y1 equal to 0 equal to 0. Now x-axis divides AB the ratio minus y1 is to y2. Y-axis divides the line AB in the ratio minus x1 is to x2. Concurrent lines. If L1 equal to 0, L2 equal to 0 are two intersecting lines, L3 also passing through the point of intersection, then L3 equal to L1 plus lambda L2 equal to 0. Suppose we have three lines which are concurrent if and only if a1 a2 a3 determinant of det of a1 a2 a3 b1 b2 b3 c1 c2 c3 equal to 0. Angle between the lines. If theta is acute angle between the lines, with slopes m1 and m2, then tan theta equal to m1 minus m2 by 1 plus m1 m2. If theta is acute angle between the lines a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0, then cos theta equal to mod of a1 a2 plus b1 b2 root over a1 square plus b1 square into root over a2 square plus b2 square. Tan theta equal to a1 b2 minus a2 b1 by a1 a2 plus b1 b2. If the point q h comma k foot of the perpendicular from the point p of x comma p of x1 y1 on the line L equal to ax plus by plus c equal to 0, then we have h minus x1 by a equal to k minus y1 by b equal to minus of ax1 plus by1 plus c divided by a square plus b square, which is the foot of the perpendicular. Suppose if q h comma k is the image of the point p of x comma x1 comma y1, then we have h minus x1 by a equal to k minus y1 by b equal to minus 2 ax1 plus by1 plus c divided by a square plus b square. Okay, 3 points are collinear if and only if x1 x2 x3 det of x1 x2 x3 y1 y2 y3 1 1 1 equal to 0.